Hello and welcome to this lecture on core concepts in artificial intelligence. In this session, we will explore what AI actually is, how it is defined, and what kinds of technologies and methods are included in the field. Artificial intelligence is a broad and sometimes confusing topic, so the goal today is to give you a clear and structured overview that will help you understand the fundamentals. We will go step by step from basic definitions to different AI areas, and finally to how AI is used and what it might become in the future. By the end of this lecture, you should have a solid foundation that will make it easier to understand more advanced topics later in the course. Let's begin with a basic but important question. What do we actually mean when we talk about artificial intelligence? AI is often described in different ways, depending on whether we focus on intelligence itself, the automation of intellectual tasks, or the attempt to build machines that can act in ways we associate with human thinking. In this part of the lecture, we will first look at how AI became established as a field, and then compare a few influential definitions. We will see that, although these definitions differ, they often point toward a shared idea. AI is concerned with machines that can perform tasks involving cognition, perception, learning, reasoning, and decision making. Finally, we will connect this to the idea of rational action, the ability of an AI system to evaluate information, choose between possible actions, and act in ways that help it achieve a goal. This gives us a practical starting point for understanding AI as both an academic field and a set of technologies designed to support intelligent, goal-directed behavior. The modern field of AI is often traced back to the 1956 Dartmouth Summer Research Project on Artificial Intelligence. This marked the beginning of a concerted effort to create machines and systems that can mimic or resemble human intelligence. Essentially, AI involves constructing entities that can perform intellectual tasks typically associated with human cognition. These tasks include reasoning, learning, perception, and decision-making. AI is broadly defined as the simulation of human intelligence processes by machines, especially computer systems. It aims to enable machines to think, learn from experience, and adapt to new information much like humans do. Over time, AI has evolved to encompass various subfields such as machine learning, natural language processing, and robotics, all working towards the goal of making machines capable of autonomous, intelligent behavior. This foundational understanding helps establish AI as a distinct and definable academic discipline, paving the way for future research and applications. AI, or artificial intelligence, is a concept that has been defined in many different ways by scholars and experts, reflecting the diversity of perspectives in the field. Max Tegmark views AI as intelligence that is not biological, emphasizing the distinction between natural human or animal intelligence and the intelligence exhibited by machines. Another perspective, offered by Cholet, frames AI as the automation of intellectual tasks that are typically performed by humans, highlighting the functional aspect of AI systems in taking over cognitive responsibilities. Additionally, Siam and Sharma describe AI as the simulation of human intelligence in machines programmed to think and act like humans, which underscores the goal of mimicking human cognitive processes and behaviors. These varied definitions illustrate how AI encompasses a broad range of ideas, from the nature of intelligence itself to the practical implementation of intelligent behaviors in machines. This plurality of definitions is important to understand as it shapes how we approach the study and application of AI technologies. According to Walsh, 2019, there is broad agreement that artificial intelligence is concerned with giving machines capabilities traditionally associated with humans or other intelligent beings. These capabilities include cognition, the ability to process information and reason, perception, the ability to interpret information from the environment, learning, the ability to improve through experience, and decision-making, the ability to choose actions based on available information. A related idea, highlighted by Frankenfield, 2019, is that AI systems are often designed for rational action. This means that an AI system evaluates information, considers possible actions, and selects actions that increase the likelihood of achieving a specific goal. In essence, AI is not only about copying human intelligence, it is also about building systems that can act effectively, adapt to situations, and pursue goals in a structured and rational way. From the outset, this session has organized AI around a core question and a practical framework. We began with multiple ways to define AI, from Tegmark's emphasis on non-biological intelligence, to Chollet's focus on automating intellectual tasks, to Siam and Sharma's description of AI as machines programmed to think and act like humans. Yet despite this definitional diversity, these perspectives point toward a common ambition, enabling machines to perform tasks involving cognition, perception, learning, reasoning, and decision-making. We also noted that AI includes familiar domains such as machine learning, natural language processing, and robotics, each of which represents a different way of building systems that support intelligent behavior. Finally, we highlighted rational action as an important guiding idea. This means that an AI system evaluates information, considers possible actions, and acts in ways that increase the likelihood of achieving a specific goal. The key point is that AI is not a single monolith, but a family of approaches concerned with building adaptable, goal-directed systems. As we move forward, hold this frame. AI studies how to build machines that perceive, learn, reason, and act to meet goals in changing situations.